to set 4A, this is 45 meter. This is also 45 meter. A person moves from location A to location B, starts with initial velocity 0, accelerates at 4 meter per second square. I ask you to find his velocity at location B when he runs off. Velocity at the x direction, velocity at the y direction. Runs off 45 meter down. So I asked you to find his velocity. The same thing over here. The person moves from location A to location B, runs up to location C, which is 45 meter down. I ask you to find his velocity at location C as well as his velocity as location B if he accelerates with 2 meter per second square and distance from A to B is 18 meter. Let's say not 18 meter, let's say this one is 25 meter and this one is rather 18 meter. So let's find the problem and see, understand, to help you understand why I have two scenarios, right? To help you understand something, a big idea. All right. So D is equal to VIT plus half AT squared. This is how we're going to start our conversation. So D is 18. VI is 0. Plus half acceleration. This is not acceleration due to gravity. This is acceleration given. Acceleration due to gravity at the x direction is 0. So this is 4 and this is t squared. So 18 is equal to 2t squared and then t squared is equal to 9. So t must be 3. If t is 3, then let's see what is his velocity right there. His velocity Vf is equal to Vi plus At. Vi is 0. Vf is equal to A is 4 times T is 3. So his velocity over here is 12 meter per second. And velocity in the y direction is by definition 0 meter per second. When he runs off, velocity at the y direction is 0. Good. Now let's find this one. So what we are finding? We are finding fast the time. Well, the good thing is, yeah, that's right. We are finding how long did it fall. So D is equal to VIT plus half AT square, right? So D is how long did it fall? 45 meter. Don't forget to put negative. VI at the y direction, of course. So at the y direction, his velocity is 0 minus half 10 t squared. So negative 45 is equal to minus 5 t squared. Negative 5 goes to negative 45 9 times. So t is 3, right? So his velocity final should be Vi plus At. Vf is equal to Vi at the y direction is 0. Negative 10, and how long did it fall? 3 seconds. So Vf is negative 30 meter per second. So is Vy is negative 30 meter per second, and Vx is of course 12 meter per second. Right? What you discover from this big idea? You discover that acceleration due to the velocity at the x direction does not change, right? Because acceleration due to gravity at the x direction is 0. Once again, velocity at the x direction remains constant or does not change because acceleration at the x direction is 0. Velocity at the y direction, or rather speed at the y direction, changes because acceleration due to gravity at the y direction is at the same direction as acceleration due to gravity. Okay, so velocity at the y direction changes is because acceleration due to gravity at the y direction is negative 10. Okay, good. So now let's see whether this one can help you understand something over there. Let's first find his velocity over there. So D is equal to VIT plus half AT square. What does that mean? 25 is equal to 0 and plus half 2, we are trying to find t square. So t square is 25, so t must be 5. We are trying to find his velocity at location B. Vf is equal to Vi plus At. Velocity is 0 because he start from 0 second. I'm sorry, he start with 0 meter per second from 0 second. Okay, so then Vf is 2 times 5. So a velocity is 10 meter per second. All right, this one is of course 0 meter per second because at the y direction it doesn't matter, is by definition 0 meter per second when you run off. Now you probably thinking that the Vy, right, Vy gonna be different because the Vx is different. All right, you probably think that Bx is 12, so this Boy is negative 30, and this Bx is 10, this Boy would be something else. No, it's still negative 30 meter per second. Why is that? It's because this Vx has no effect. This Vx has no effect with the velocity at the y direction. Now this Bx has to be the same because why is that? Because acceleration due to gravity at the x direction is 0. If the acceleration due to gravity at the x direction is 0, there is nothing to affect the velocity at the x direction. That's the point I'm trying to make. All right. So this is the problem number 1 or idea number 1. Now let's move to idea number 2. So idea number 2, I gave you few boxes, right? 1, 2, 3 boxes, and I ask you to, let's start with velocity, initial, time, displacement, distance. I gave you, I think, 7 quantity: velocity, speed, and then acceleration due to gravity. And I ask you to drop an object from 45 meter above the ground. If you do drop an object from 45 meter above the ground, how can you complete this? The ball will fall to the ground, like this, right? Okay, so let's first find your initial velocity. When you drop, this is a drop. Dropping by definition, initial velocity is 0. So at 0 second, it is 0. If it falls for 45 meters, so how long does it take for it to fall? D is equal to VAT plus half AT square, and that gives you the answer. Okay, so it falls for 3 seconds. Okay, it falls for 3 seconds. Good. Then we also want to know what is happening when it was in the middle, like, half. Yeah. One thing we know that since displacement is quadratic and velocity is linear, displacement would increase quadratically. Okay, so keep that in mind. So between 1.5 to 3, it displaces more than between 0 to 1.5. That's the point I'm trying to make. Okay, so when the time is 0, displacement is 0, distance is 0, velocity is 0, speed is 0. However, acceleration due to gravity is negative 10. Acceleration is due to gravity is negative 10, regardless what you're doing. Okay, good. Now, initial velocity is 0, regardless of the time. Displacement at 1.5 second is d is equal to VAT plus half AT squared. So d is equal to VI is how much? 0 plus half negative 10, 1.5 is squared. So 3 over 2 is squared. So this is negative 5, 9 over 4, right? So this must be, displacement must be negative 11.25. So displacement must be negative 11.25. Distance is 11.25. Velocity, let's see the velocity. Vf is equal to Vi plus At, and vi is 0, so vf is negative 10, 1.5, so 15, and this is 15, right? And now let's see at the end of the 3 second, how much does it fall? Of course, negative 45. This is positive 45. Velocity is vi plus at. Since it's free fall, vf is equal to negative 10 times the total time it falls, 3 seconds. So negative 30. All right, speed is absolute value of negative 30. Okay, so that's it. That's the idea number one. Idea number two. Idea number three, or question number three, is you position versus time. Time. I throw a ball up in the air, okay, with 90-degree angle right here. Initial velocity is 10 meter per second, right? I ask you, I gave you like many quantities. I gave you velocity, initial, time, displacement, distance, speed. All right, so what do we know? We know our initial velocity. What is that? 10. We know our initial time. What is that? 10. We know when the time is 0, displacement is 0, distance is 0, velocity is 10, speed is 10, and acceleration due to gravity is negative 10. Which is negative 10? No matter what. Initial velocity is positive 10 at no matter what, regardless the time. Okay, so how long the trip was? To find how long the trip was, one thing we must do is finding the VF. Since it is symmetric, it is parabola, okay, we can cut this in half. What does that mean? It takes the same amount of time, right? Okay, this takes same amount of time than this. This one take, if this one take x second, this one also takes x second. All right, so if this takes uh, that means if the initial velocity is 10 meter per second, final velocity is equal in magnitude but opposite in direction. So let's write the final velocity. uh, if we know final velocity, we know final time. So vf is equal to vi plus at. Final velocity is negative 10, initial velocity is 10, negative 10 t. So negative 20 t is equal to negative 20 is equal to negative 10 t, right? So t is equal to 2. So that's what we're going to put, t is equal to 2. And we try to understand what is happening, how the ball behave, location of the ball, information of the ball when the time is 1 second. When time is 1 second, displacement is, all right, time is 1 second, displacement is, initial velocity is 10, 1 plus half negative 10, 1 squared. So that means this one is 10 minus 5, 5. From here to here, 5 meter. Distance is also 5 meter. Velocity, all right, velocity vf is equal to vi plus at. Velocity is how much? This is 10. So vf is 10 minus 10 at the end of 1 second. Okay. So initial velocity is, oh, at the end of 1 second, velocity is 0 because velocity is 0 over here by definition. Speed is 0 over here by definition. Okay, good. All right, so everything looks good. Now we want to find the displacement at the end of 2 seconds. Displacement is 0 because object returns to the same location. Distance should be, if from here to here is 5 meters, from here to here must be 5 meters. It's 10. Velocity at the end of 2 seconds. Final velocity, which is negative 10, right? Speed is 10. We finish it. Now we're going to draw 6 graph. 1, 2, 3, 4, 5, 6. This is distance versus time, speed versus time, acceleration versus time, displacement versus time, velocity versus time, and acceleration versus time. Distance versus time, okay, from 0 second, okay, the entire trip is 2 second. All right, the entire distance is, of course, 10 at 2 seconds it moves 10 meters. So 10. Enter displacement is 0. Okay, so that's good. Maximum height is 5. Maximum velocity is -10. So +10 to -10. Okay, maximum speed is 10. So from here to here is speeding down. So how can we show the speed is speeding down? Is speeding down. From here to here is speeding up. Is speeding up. All right. Now speed from 0 to 1 second is speed down. 1 to 2 second is speed up, and acceleration is remain constant. Okay. From the displacement versus time, all right, maximum height is 5. At 2 second, the displacement is 0. The velocity is decreasing to 0 from 0 to 1 second, and the velocity is increasing from the magnitude of the velocity is increasing from 1 to 2 seconds. If you find the area under the curve, which you have to, this one plus this one is gonna give you 10, right? This one is 5, this one is 5, altogether 10. This one is 5, this one is -5, so the displacement is 0. Acceleration is g, -10. Okay, now the last one, we are throwing an object down. So down 45, from 45-meter tall building. If you throw down something, oh, we already know -2 meters per second. We want to know many things. So you want to know initial velocity, we want to know the time, we want to know displacement, we want to know distance, we want to know velocity, we want to know speed, we want to know acceleration due to gravity for these many locations. All right, when the velocity, when the time is 0, velocity is -2. In fact, velocity is -2. And regardless of the time, acceleration doesn't depend on the time. Acceleration due to gravity doesn't depend on time. So you're just gonna keep putting those things. At 0 second, the displacement at 0 second, the displacement is still 0, distance 0, velocity is -2, speed is 2. How long the entire trip was? T is equal to VAT plus half AT squared. How much time? D is, it was falling 45 meters, so you must put -45, -2t, -5t squared, because A is -10, acceleration due to gravity. So 5t squared plus 2t minus 45 is equal to 0. So you're going to have to use quadratic formula, minus b plus minus b squared minus 4ac over 2a. So b is, you have 2, so -2 plus minus 2 squared, which is 4. 4 times 45 times 5, that's going to give you 900 positive, and that 2 times 5 is 10. So square root of 900 is 30. 30 minus 2 is 28. 28 divided by 10 is 2.8. And 2.8 is good. Why? 2.8 is smaller than 3. Although this ball also dropped from 45-meter high, however, it took 3 seconds because initial velocity was 0 meter per second. This ball also got dropped from the same height. It took less time because initial velocity is not 0. That's it. Okay. Now 2.8, we need to know, okay, so this one is, let's say this one is, I don't know, this one is 1, right? At 1. So displacement at 1, displacement is BIT plus half AT square, right? So now this is -2, 1, -5, 1 square, so -7. Displacement is -7 at 1, at the end of 1 second, right? Now velocity is how much? Vf is equal to Vi plus AT. So this is -2, -10, of course, at the end of 1 second. So -12. At the end of 1 second, velocity is negative 12, speed is 12. At the end of 1 second, the displacement is the whole thing, negative 45. Distance is 45. Velocity, okay. At the end of 2.8 second, the velocity is Vf is equal to Vi plus At. Vi is negative 2, negative 10, 2.8. So Vf is equal to negative 2 minus 28. So negative 30. And this one is positive 30. Okay.